as quick as possible. Probably today, but maybe tomorrow. All right, depending. All right, because I want you to take a look at it. I want you to get started, and especially those of you guys who would like to make 100 or like to make an A+, so your grade will move. All right, you need to start studying. Okay, so similar polygons. All right, so anytime somebody says something is cylinder or is similar, what's true about all the angles? The angles are what? Congruent. All right, when you blow something up, do the angles change? No. Do the sides change? Yes. So we say when figures are similar, the angles remain the same and the sides are proportional. That's how simple this is. All right, and again, we did this in 6th grade, where our basic geometry class, we learned about proportions, and we said this is similar to this, so then you make your proportions and solve. Are a little bit more complicated now, but it's honestly the same exact. All right. Now, if somebody says to you, here is the symbol. All right. Triangle ABC is similar to triangle XYZ. All right. What that means is this: that angle A corresponds to angle X. Is everybody hearing me? Angle B corresponds to angle, and angle C corresponds to angle. Angle A is congruent to angle X. Angle B is congruent to Y, and angle C is congruent to Z. That's kind of like the congruent statement. The angles of similar figures are always congruent. The sides, we say, are what? Proportional. All right? So I would say what? I would say AB over XY is equal to BC over YZ is equal to AC over XZ. AC is to XZ. Is that confusing? You got it? Okay. So again, the fundamentals, the basics, right now. Do anybody have any questions? So sides are proportional, right? And angles are congruent. So when somebody says, use the similarity statement, it's like the congruent statement. That is the similarity statement. That's how you set up your proportions. All right? I tell kids a lot of times, don't go by off the figure, but go by off of the similarity statement. 100% you'll get it right if you go by the statement. You can be tricked by how they flip or rotate the figures quickly. Yeah, it doesn't matter. All right, it doesn't matter. But, you know, AB technically is to XY, even though it doesn't matter technically if you say AB to YX. Do you understand what I'm saying?
Yeah.
All right. So again, it's the direction that you're traveling is important, but not really. All right. So let's look down to see if you understand what I'm saying. All right. And again, guys, just you don't have to waste time. All right. I'm just trying to show you how simple it is. You don't have to write all this out because I think we've already done it, honestly, in 6th grade. All right. We did do this. All right. If I say triangle DEF is similar to GHJ, they want you to list the congruent angles. So we would say angle D is congruent to angle G, angle E is congruent to angle H, and angle F is congruent to angle J.
You don't really even need to figure.
You don't even need to figure. I would argue that's how they trick you when you take standardized tests.
Like
They give you the figure and then they twist it or reflect it. What?
Like I see now it says like how you can follow DEF and DHJ, but like if you look at the triangles, E is how is.
Yeah, that's what I'm saying. I'm telling you. That's the whole point of the lesson. Listen to what I'm saying.
Prove that they can be
Yeah, exactly right. Exactly right. Listen to me. That's why I'm telling you. I tell kids, instead of looking at the figure, you should only look at that. 100% correct. You can't miss it. You can look over there and say, man, I don't know if G goes with F or D. Right? I don't. Or it might be an isosceles. It might be interchangeable. One might be 60 degrees and the other one might be 59. I don't know. You You with me on that?
Right.
So again, that's why I say going off the figure is not the safest way to do it, right? Now, if you look at the next figure, you can see how, to me, it's rotated. It looks rotated, but I don't even care because they give me this information right here. So I know PQ over TU is equal to QR over UW, which is equal to RS over WX, which is equal to PS over TX. Now, I hope the way I said that, you can say that's exactly what I'm saying. Right? There's no reason to write it down, in my opinion. That's just common sense. But I say it's common sense, then people blow it. So I don't know if it's common sense to you. That's what I'm asking. Does everybody see my pattern, right? I'm just going PQ, TU. And then I go QR, and then I go UW. And then RS and WX. And then PS and TX. It goes in clockwise or counterclockwise. You can't skip around. I can't say PR and TW. Those would be diagonals. You with me on that? Those would be diagonals. And if you're not sure, it might be able to show you over here. Yes. You with me? No, I'm just pointing it out because those are the common mistakes. I'm doing that for a reason. Or I'm doing that for a reason.
So basically, when it has 4, or when it's like a
yes,
4, and you can only go to the side.
That's 100% correct. Right? Because think about it again, and I always try to make kids understand the logic. Because you read the numbers, or you read the letters either clockwise or you do what? Counterclockwise. So QR is a side. RS is a side. That's what I'm trying to get you to understand. All right? And once you understand that, to me, it makes it simple. All right? So the sides are proportional and the angles are congruent. All right? Now, let's look at question number 3. Determine whether each pair of figures are similar. So in order for them to be similar, all of the angles, the corresponding angles have to be congruent, correct? So over here, I'm looking at number 3. Yes, perfect. Exactly correct. Is everybody with me on that? But I kind of like what Joe said, to be perfectly honest. I look at one, the obvious is one's 90. If one of them's 90, then one of the other one has to be what? 90. All right? If I have 3 figures angles that are equal, only what? 3 are allowed to be equal over here. So there's lots of ways to show that it's not. All right? And again, all I'm asking is just stop me now, guys, if you're not sure about something. All right? Because to me, this is just so obvious.
If 4 of the angles are congruent, does that prove that they're similar?
No, listen to me. That's a very good question. We're going to come up to that. And I'll tell you why. Think of a square and think of a rectangle. Square and a rectangle are not similar, but their angles are equal. You see what I'm saying? It's very confusing. Because it sounds to me like all rectangles should be similar. All rectangles should be similar in my mind. That's when I was first thinking about it. But that's not true, right? Are all squares similar? The answer is yes, because all the sides are the same, and if you put them on if you do a proportion with the other sides, it'll be the same. All right, so all squares are proportional. Just because the angles are congruent does not make the shape similar. All right.
The sides have to be congruent.
Yes. All right. Not congruent, but proportional.
What if all the sides are congruent and they don't say anything about that?
So that's another good question. So you can draw a square and you can draw a rectangle, right? So because the sides are congruent.
All right, yeah. So then they're not.
You see what I'm saying on that? All right. So again, all good examples. But they're not going to trick you on this. They'll give you the shape and you can easily be able to tell. So let's look at this guy right here. So does everybody agree that PQR is similar to PST? Let's first check the angles, right? So P corresponds to P, right? It sounds weird. Q corresponds to S, and R corresponds to T. Now, the ratio of the sides, you should be able to see, is 1 to 2. 11 over 22 is 1/2, right? Yeah. If this is x and this is x, then the whole length is what? 2x. So x over 2x is still what? 1/2. And then this over here is y. This is y. Y over 2y is 1/2 y. So that's a really good problem. All right, because it kind of doesn't look like it's similar. Because it looks like the ratio of the sides is 1 to 1 instead of what? 1 to 2. That's how they trick a lot of kids on that question. All right. Let's go now down here. All right. So now they're saying if they are similar, then the sides are what? Proportional. Now here's how I like to set it up if they don't have a similarity statement. So please watch this. All right. 10 is between 1 and 2. Do you understand what I'm saying? 10 is between the angle that has 1 and the angle that has 2. So I would say 10 over, and then that would be this guy right here. So can I really use that? No. Does everybody see that now? Right, so the 10 is there to kind of do what? To throw you off a little bit. 10 corresponds to this, which is not helpful because we don't know what that is. Right? So now 8, watch, 8 corresponds to 0 and 1. So 8 over 0 and 1 is what? 12.
And then 9 over x.
And then x over 9. Everybody with me on this? Anybody have any questions with that? Yes?
Could you use Pythagorean theorem?
No, because first of all, we don't know it's a right triangle. You with me on that? All right, not a bad thought, but we don't. Yes. All right. Now, in my opinion, 72 divided by 12 is kind of easy, 6, right? But if you wanted to, I always try to tell kids, reducing the fraction sometimes is helpful. Did I see that? There you go. 3 times 3 is 9. 2 times 3 is 6. So x equals 6. Did everybody see that? Reducing the fraction is
A
important.
lot of that was on the Jesuit.
Why is it 2/3?
Because if you recall, that was whatever that fraction was, 8 over 12.
Why is 8 over 12 equal to x over 9?
Because from the figure.
Yeah. But like, why?
How did I set the proportion up?
Yeah.
Okay, so watch. I intentionally selected 10 first to show you that's not helpful.
Right, because it's side.
Right. So then I just picked 8. Right?
And it
So I
corresponds
picked
to 12.
8, and 8 corresponds to what?
12.
That's why it's 8 over 12. And then x corresponds to 9.
What about like in the problems that 2 of them aren't going to be like the same?
We'll get to it, I promise you. All right. Each one a little bit easier, I think. All right. So over here, right now, does everybody understand on this right here, guys, that 5 and 10? I prefer to look at the relationship. The large trapezoid is what?
2 times 3.
2 times bigger. Come on now. You're supposed to be able to see that. Right? Does everybody see that? So then x would be 2.25, which is a common mistake.
Oh.
Right? It doesn't matter. No, listen. What I'm saying, guys, is the same thing, guys. Just make the silly mistakes now. All right? Does everybody understand what I'm saying? We're going large to small or small to large.
Yeah.
Right? I want you to look at the number 5 and look at the number 10. It's twice as big. And then you just say, are you getting bigger or are you getting smaller? In my head, that's all I'm doing. One is twice as big or 3 times or something as big, and the other one is something small. All right? That's how I look at it. I either multiply or I divide. I don't even set up a proportion, and some of you guys understand exactly what I'm saying because that's what we did in 5th and 6th grade. We just said, this is 3 times bigger than that. Or this is half as big. All right? So you're looking at the numbers. Let me explain what I'm talking about over here. Look over here, guys. Please go back. All right? So if I take 8 and I divide it by 12, or let's do 12 divided by 8. That's 1.5. Does everybody agree with that? Come on, listen to me now, please. This is kind of important. because I like this way of doing the problems in the first place. So one triangle is 1.5 times bigger than the other. Everybody agree with that?
Yeah.
So you're either multiplying by 1.5 or what?
Dividing.
To me, that's how I do all proportions. Does everybody understand what I'm saying? What I'd like to look at it is it's so many times bigger. And I try to do the big one over the small one. All right, but it's not necessary. All right, so I'm either multiplying by 1.5 or what? Dividing by 1.5. So in this particular case right here, I'm looking for x. So if I take 9 and divide it by 1.5, I should get the correct answer. You agree? All right. Now, if I wanted to look at this right here, what's the length of, well, what looks like the hypotenuse? What is that? Obviously,
Times
15. Thank you. Multiply by 1.5. Does everybody see how simple that is?
Yeah.
All right. I like to find the scale. How much bigger is the other one? And just multiply or divide, depending upon if I'm getting what? Bigger or smaller. To me, that was the easiest way to do these problems. All right. Hopefully you agree, but let's take a look at number 3. All right. So again, what I'm looking at right here is the scale. Look up, please. So this is this. Does everybody agree with that? So do 18 divided by 12. What's 18 divided by 12? 1.5. So the big one, listen to me, the big one is 1.5 times larger than the small ones. Everybody agree? So now I have 24. So what do I do with 24 and 1.5? Divide it. So somebody take 24 divided by 1.5. What is it?
It's 18. 617.
No, I'm not asking for the answer. I'm not asking for the answer. I just simply said, what's 24 divided by 1.5?
18.
Is somebody sure it's 18?
Yes, it's minus.
No, it's 16.
I think it's 16.
Yeah, it's 16.
It's 16.
It's
Right?
8. That's the average.
So if I divide 24, here's how you should look at it. If I said 24 divided by 1.5, that's the same as 24 divided by 3/2, which is the same as 24 times 2/3, which is 16. Now you got to be real careful now. Think. I want x. What do I want x to be? So that length is 16. You with me? Hold on a minute. You see why it's 15 and not 17? Because I'm not asking you what. I'm not saying x is 16 here, guys. I'm not saying x is 16. You hear what I'm saying? That whole length is what?
You're saying X is 50.
Yes.
Why is it 16?
Because 24 divided by 1.5 is what?
Why 1.5?
Because what's 18 divided by 12?
Why are you doing 18 divided by 12?
Well, what do you want to do? Let's go with that.
What?
Shh. No, I'm not. Listen to me. You think I'm not trying to be, I'm totally being honest. I'm not trying to be funny. I'm asking you, what do you want to
What
do?
is that doing?
I'm
what are you
finding
finding?
how much bigger the other one is than the other.
So you have to
Like this
divide
over
two
here.
sides.
Yeah. So look right over here. This is what I was trying to show you over here, which I think is super important for kids to understand.
Yeah.
I've got a relationship of 10 and 5.
Yeah, you have to.
The
see
big
what
one is
relationships
what?
there are. Yeah, I get that.
Is how many times bigger?
2 times bigger.
How did you get that?
Because 10 and 5. That's half. Yeah.
Or 2 times. 10 divided by 5 is 2.
Yeah, I get
So it's the same principle, kiddo. All I'm doing over here is going 18 and dividing it by 12. What's 18 divided by 12?
1.5.
So that means this is 1.5 times greater than that. So if this side is 24, I'm going to a smaller side, so take 24 and divide it by 1.5. And that ended up being 16. So x was what? 15. Because you would say x plus 1 has to equal 16. All right. Now, if you're going, man, that's just dumb, I don't know what you're doing, then you just set up a proportion. Honestly, you just say 12 over 18 is equal to x plus 1 over 24. I do smarter than that. I don't need to do all that. All right, what?
X is equal to 16.
That's what I'm trying to ask you.
X is
No.
No, x plus 1 is
No.
Yeah, listen to now, William. Listen to me for a second, because William, I think you're doing exceptionally good now. Listen, you're always trying to figure things out, so that's where you should be. So now, listen to what I'm trying to tell you now. Here's what I'm trying to make sure that it makes sense to you. You ready? Listen to me. So this over here length is 24, right? You said confidently divide that by 1.5. Do you agree with that? So if I divide that by 1.5, that means now here's where you're having trouble. That means, listen to me, that length is how much? Well, 24 divided by 1.5.
Yeah.
And I'm hoping, see, some of you don't do the work yourself, so you just assume Joe is right with it being 16. Honestly, I really feel like that's what the problem is for some of you who want to make good grades. You simply are following along saying, yes, that's okay. I would want you to take 24 on your own calculator, divide it by 1.5, and see that that is what? That is 16.
24 divided by 1.5?
Is what?
6.
Why don't you do it on your calculator? I'm just mind blown here. All right? It's 16.
Multiply x plus, or x times 1.5.
No. Just let me finish this off. Let me finish this off so it makes sense. Because I know I should be doing proportions, but you're smarter than that. I'm trying to show you now how you really don't even need a proportion if you understand that one is just a certain times bigger than the other. You understand me? So now, did you do 24 divided by 1.5 and came up to be what?
16.
So now, listen to me. I'm telling you now, listen carefully,
Oh, I
That whole line.
understand.
Yes.
I understand. The entire line is
16. So therefore, x would have to be, x would have to be,
15.
yes. Welcome. I'm telling you, it's okay to be confused. But don't accept what I'm just saying and just go, okay, it's like Joe. That's what I'm saying. Is it 16 or 18? And some of you don't even know because you didn't do it yourself. You're just taking somebody's word for it. All right? You do the work yourself and things click much better. I promise you. Much better. Go.
So I understood 24 divided by 1.5. I did on the calculator.
I'm good with that.
So, but 24 divided by 2 is 12, right?
Yes.
And half of 12 is 6, and 1.5 is a half less than 2.
Yeah, that's what my reasoning was.
Okay, so I'm good with that. I'm good with that. But
That's
just
fine.
watch. But
I
just watch.
understand the calculator.
So here's what I want you to think about this way. Something,
I understand the 2 for
I got you. Something times something times 1.5 is 24. That's what the question is, right?
So 1.5.
Yeah. Or 24 divided by 1.5. Now, the problem you're having is I'm dividing this by 1.5. Right? Does that make sense? So I'm dividing it by 3/2. Right? Which to me was easy because when you divide by, that means you're multiplying it by. You with me?
Yeah.
And so that's 16.
And that 48 over 3 is
Exactly. So I think your mistake is dividing by 1.5 is not separating it into 1 1/2. I understand what you're saying.
Isn't that what 3 halves is? Though?
Yes, but when you're dividing by 3/2, right, you're separating it. Then the reason why this is harder mentally, in my opinion, is because I'm picturing this. I'm picturing 24 divided by 2, which means I'm separating it into what? Into 2. Right, but how do I divide something by 1.5? You see what I'm saying? I'm trying to separate something into 1 and into 1/2. So visually, that's kind of hard to do. Does that make sense? All right, go. I'm listening seriously. Go.
What I did is divide it, like if it's 3 over 2, you divide by 3.
Yes, that's what I do. That's always what I do. Always divide first. I tell kids that all the time. Right? Okay, so let's see if you understand what I'm saying now. Let's look at this guy right here. So does everybody understand how this one is what? The large one is what?
Something 40
It's
divided by
4/3.
Right. So again, so now we're going to learn that we're not going to say 1.3 repeating. We're just going to say I multiply the small one by what, please? 4/3 to get the what? Large one. Or I multiply the large one by 3/4 to get the smaller one. Listen to what I'm saying. Does everybody understand that?
Yeah.
Right? To get from the large to the small, you have to, think about it now, to get from the large to the small, you're going to divide or multiply by the reciprocal.
Okay.
Yes.
So since the 18 and 30 are both divisible by 3, can't you just divide by 3 and multiply by 3?
Well, there's so many ways to look at it. There's so many ways, but again, I'm trying to stay consistent. What I know for sure is that the 40 over 30, right? So I have to multiply 18 times 4/3 to get this length.
Yeah.
So if I multiply that, it would be what? 24. So I know x had to be what? 9.
But 30 divided by 3 times 4 is 40. And 18 divided by 3 times 4 is
If you divide 30 by
Right.
3,
So then 24 minus 15 is 9.
Yeah, I'm not. Look, I'm trying to tell you now. What you're not understanding is there's so many ways to do it. I'm not arguing with you. I'm just trying to stay consistent. I'm either multiplying or dividing to get the other side. That's all I'm doing. All right. There's proportions. Some kids just say, can I just set up the proportion? Yes, set up the proportion.
Yeah.
I'm totally fine with that. I'm trying to get you to see, look, it's just one is so many times bigger than the other. That's it. All right, so let's take a look at 5. So they're similar. So to find the scale factor, the scale factor is what our 1.5 was. Does everybody agree with me? Now, it's either 1.5 or it's 2/3. Does everybody agree with that? So you can be wrong here. All right, so listen carefully. It's the scale factor of ABCD to PQRS. So is it going to be greater than 1 or less than 1? Less than,
4/5,
right? Why?
It's 4/5 because it's 25. 20.
Because it's asking you for the short
Yeah.
to the what?
Long.
To the long.
Yeah.
So it's got to be, the scale factor will be less than 1. Everybody with me? So again, it's not that you're wrong, but it's that you have to look carefully, right? So if something is 2 times bigger, it's 1/2 smaller. You understand what I'm saying? So in this case, it's asking ABCD to this right here. So it's just 20 over what? 25, which is 4/5. You agreeing with me on that now?
Yeah.
So the scale factor is just 4/5. So if I'm trying to find the smaller side, I would multiply by 4/5. If I'm trying to find the larger side, I would multiply by 5/4. Good. Now you understand what I'm thinking. Right? I think that's the easiest way to do it. Is that it? Okay, so guys, listen to me. Just try. You can see how simple it is. There's 4 there. Or I think it's super easy. Just do me a favor. Just make sure you know what we're doing. All right, go through, pick a few problems, look at each one, make sure you understood what I was saying clearly, because I am getting your exam review because that's important as well. All right, so get busy.
Okay,
All right,
math,
figure that
I
out.
have to get a 95. If I get a 95,
What are you going to